Okay, so we're going to end this year or this semester talking about environmental exercise physiology. Now, this is going to be an introduction of what I talk about in my PE 480 class. It's a class that's only offered every other year, so if you're graduating in the next 12 months, you wouldn't be able to take it. But if you find this stuff interesting, you need an elective, you're thinking about doing something with athletic training, I think this is a very beneficial class because we have to deal with the environment. And so that's what we're going to do over the next 4 lectures. And so our first one, we're going to be talking about the environment. Second one is heat. Third one is cold. And then the last one is altitude. And so we're going to keep this very basic. And then, like I said, if you find this really interesting and have the ability to, I would encourage you to take exercise or PE 480 during the spring of 2023. But again, that's only for people that are sophomores right now. So here we go. So we're going to take 2 lectures to talk about, or 2 videos to talk about the environment, and then 1 to talk about heat balance. Okay, but really with the physiology of what happens when it's hot outside, we'll talk about with the second lecture of this, second set of lectures. All right, so here are our 3 objectives for this little mini lecture. So the question is, well, how do we deal with the environment? We're going to get into the terminology here. And so we've got stressors. Okay, and this doesn't just apply to environmental exercise physiology. This applies to anything. But when we're talking about the environment, we're just talking about environmental factors that challenge homeostasis. Okay, so exercise isn't an environmental stressor or an environmental thing, but it's a stressor, right? And then you've got heat, cold, hypoxia, hyperbaria. So that's like with increased pressure. So think scuba diving. When these stressors come, we have some sort of adaptation. And so this is the change that we undergo to minimize that strain. Okay. And then we've got accommodation. And so these are kind of immediate changes that counteract that stressor. So think of if your body temperature, your core temperature increases, you sweat. Okay. So it's an acute response. It's something that you have the same response every time you experience that stressor. Okay. If we experience this stressor long enough, we experience what's called acclimatization. Now, you could think of acclimatization, it's kind of like an analogy or a parallel to that is if I lift weights, right? If I do a lot of bicep curls, my biceps are going to get bigger, right? And so acclimatization is a similar sort of thing. It's not going to increase the size of my muscles, but there's going to be physiological changes that make it easier for us to handle that stress. Okay, so for example, I'll become more efficient at breathing when I get up to altitude. I'll have increased red blood cell if I get at altitude. Those are things that happen as a result of acclimatization. Now, these long-term or chronic changes, we classify that as acclimatization if this is something that happens due to a natural environment. So meaning if I want to become acclimatized to altitude, I go live on top of a mountain. That's acclimatization. But we can also have acclimation, which is when you stimulate these stressors or experience these stressors in an artificial setting. Okay, so meaning, hey, you just go hang out in the environmental chamber in ex-phys lab and you just live there and you always have it set to hypoxia, so really low oxygen. Okay, and then you've got some genetic adaptations. And so with these genetic ones, these are things that happen over generations of time. Okay, and so due to natural selection and things like that, these are changes that make it easier for a population to live with this stressor. Okay, so for example, Tibetans are able to handle high altitude better than Sealanders, for lack of a better term, right? And there are changes that have occurred. They're better at breathing, that sort of thing, that make it easier for them to survive at high altitude. Excuse me. So with this, we're going to kind of transition a little bit into some thermal terminology. So heat is just a measure of the energy of motion. Okay, so in a gas, remember the atmosphere is a gas, molecules are moving around. When they move fast, we have more heat, okay? And so that's what heat is. It's just the movement of these molecules. Now, heat is really interesting. It can be stored, it can be converted, it can be transferred. Okay, and we're going to talk about all of these things later. Okay, especially radiation, conduction, convection, evaporation, and condensation. All right, that is how we transfer heat. And this is really important when it comes to exercising in the heat or exercising in the cold. And like many things that we've talked about, there needs to be a gradient. Without a gradient, there's no movement. Now, when it comes to temperature, temperature is a little bit different than heat. Temperature is just a measure of how hot something is, how much heat there is. And really what it is, if you're getting very specific, it's just the average kinetic energy. Okay, remember kinetic energy, or if you don't know, kinetic energy is just the energy of movement. Okay, and so based on the average kinetic energy, we have a temperature. All right, the hotter it is, the faster molecules move, so we have a higher kinetic energy. The cooler it is, the slower those molecules move, so we have less kinetic energy, we have lower temperature. All right, now when it comes to temperature, we can measure it several different ways. And what I mean we can measure it, there are several different scales. So because America, we're one of the few places that still uses the Fahrenheit scale, this is where, water freezes at 32, water boils at 212. Doesn't make any sense. They're just kind of random numbers. Celsius, it's similar, except for here, water freezes at 0, boils at 100. But in both cases, those aren't necessarily great because you can have negative temperatures, and that would imply there's negative motion. I don't understand a lot about physics, but I know you can't have negative motion. All right, and so that's where degrees Kelvin comes into play. And so it's the same scale as Celsius, meaning the difference between the numbers is the same, but instead of having water freeze at 0 degrees, water actually freezes at 273 degrees. 0 degrees Kelvin implies that there's no molecular motion, and so it's really, 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 really cold. Okay, so that's absolute zero is the lowest theoretical temperature that we can get. All right, and so generally in science we use Kelvin because it really messes up with the math if you have negative temperatures, but oftentimes we just use Celsius. And the equation the equation that shows the relationship between Celsius and Fahrenheit is here. So you can go 5/9 times your temperature in Fahrenheit minus 32, or you can go Fahrenheit equals 9/5 C, or 1.8 C plus 32. The important thing, or I think a thing that makes it easier, is that as you change Celsius by 10 degrees, you increase or you change Fahrenheit by 18 degrees. And so to give you a little visual of this, here's where water freezes at 0 degrees Celsius, 32 degrees Fahrenheit. We don't have the boiling point. And so there we go. We're increasing by 18 with every jump. Normal body temperature ranges between 34 and 40 degrees. Okay, as long as we're within those numbers, we're probably going to be okay. Once we get below 34 or above 40, then some bad things can start to happen. Okay, and we're going to stop there for now.